Problem 6-130. Kendra just made a cup of hot chocolate that was too hot for her to drink. She set it aside so it could cool off. While she was waiting, her friend Laura called and Kendra forgot about her hot chocolate. Sketch a graph that shows the temperature of the hot chocolate since Kendra first set it aside. How cold will the hot chocolate get? So I've set up a kind of a coordinate plane here. We're focused mainly on the first quadrant. And I'm just going to kind of define what our variables would represent here, or what these axes would be. This side would represent time. And this would be time since the hot chocolate was first set aside. The left side over here is going to represent the temperature. Now obviously it's cooling down, and what we're going to have here, it's going to be cooling down kind of at an exponential rate here. One thing we want to mark down is when we've got our hot chocolate, this point here, when we're at, say, 0 minutes or hours or whatever the time is there, they didn't really give us a unit of time. So this would be like 0 minutes or hours since it was set aside. So this is the initial time when it was set aside here, and this would be like the initial temperature. So as time goes on, we'll just say that, she really forgot about everything here, and let's say that we went by, I don't know, hours maybe. So each of those is going to represent an hour, and then this would be a temperature in, it could be degrees Fahrenheit or whatever you want there. So when we first start out here, let's say it's going to be the hottest it's going to be. And then, let's do this in degrees. So the temperature right now is pretty hot, and it's going to start to drop. After an hour, it's going to probably drop some. And then it's probably going to drop the next hour. And then it's going to drop a little bit more the next hour, and then it's going to drop, even less there. And what's going to happen here is our graph is going to end up representing exponential decay as it continues to drop off there. Now we could take this here and we could add in, I think I have a line tool somewhere. Maybe I don't. So the neat thing here is, and that's not a very good location, I'm just going to move it down a touch. Okay. We have this line that will run through here, and it is going to actually end up being an asymptote. Oops, it's not plural, it's just one. But what we have here is an asymptote, and that asymptote right now is at room temperature. The reason it's at room temperature, if you think about it, the hot chocolate's really hot, and then after time it starts to cool off here, but it's never going to end up getting colder than what room temperature is. So since we're at room temperature, we could say maybe this is about, I don't know, 70 degrees, depending on, what room they're in. So it'll start to cool off, and then it'll never drop below that 70 degrees or whatever the room temperature of the room is. It's going to go and just drop like that. So it says sketch a graph and show the temperature, or shows the temperature of the hot chocolate since Kendra first set it aside. How cold will the hot chocolate get? The coldest will be room temperature. Hopefully this kind of helped you out there. This is problem 6-130. If you have additional questions, make sure you ask your teacher. Otherwise, thanks for watching.